Hello everyone. Today we will do a recap of the first order differential equations. We will concentrate only on two methods. So the first one is the separable equations when you have your dy by dx, and on the right hand side you have the combination of two functions. One of them is purely of x, another one is purely of y. So which means that you can separate the variables. Let's just have a look at one of the examples and how we apply that. First of all, we have our dy by dx, which equals our x minus 5 divided by y squared. So the first step of this algorithm is to separate the variables. We can actually do so just simply because if you multiply both sides by y to power minus 2, and then if you multiply everything by dx. So as the result, you will have your dy y squared equals, and then you have x minus 5 by dx. Which means that we can integrate both sides right now. And this is the power function, which means that we will have our y cubed over 3. And here we will have, this is power function, which gives us x squared over 2 minus 5x. And because we're integrating in both sides, we have constant of integration, but because constant plus constant will give us a constant, we just move this to the right-hand side. This is the explicit solution of our equation. And now what we can do, we can find the explicit solution, which means that we isolating y on one side. So which means that we multiplying both sides by 3 and taking the square root or cubic root of both of them, which gives us cubic root of 3 over 2 x squared minus 15x. And then if you have 3 multiplied by c asterisk, it gives us just simply another constant. So we're just writing down this as c. So this is the application of separable equations, and that's how it's done. In some cases, we can apply a different method. So the different method is used, and we call this integrating factor. Every single equation, first order differential equation, can be written in the format dy by dx plus some function of x by y equals q of x. So this is the standard form. Once again, let's just use one of the examples to see and to follow the algorithm. So one of the examples is x by dy by dx. Then we have plus 2y equals x to power minus 3. So this is our equation, and the first step is to write it down in the standard form. To do so, we need to isolate x. So we need to get rid of this x, which means that we need to divide all sides by x, which gives us our equation in the standard form. This is the end of the first step, so we wrote it down in the standard form. Now we need to locate our p and q. So p is a multiple of y, which means that our p of x equals 2 over x. And then q is our right-hand side, which is our x to power minus 4. So when we identify that, we are ready to move to the second step to find our integrating factor. So our integrating factor is always e to power integral of p of x by dx. In our case, p is 2 over x, which means that we have our e to power integral of 2 over x by dx. Then it gives us e to power 2 natural logarithms of x. We don't take into account the constant of integration. 2 can be moved into power of x. So we have e to power ln of x squared, and e to power ln gives us just the argument of our ln, which gives us x squared. So we obtained our integrating factor. The next step is to apply this to the equation. So we have our equation mu of by y equals integral of mu by q by dx. So we have all information needed, which means that we have x squared y equals integral of x squared, and our q is x to the power minus 4 by dx. Combination of this will give us integral of x to the power minus 2 by dx. And we need to do the integration. So the integration then will give us, so if we have x to the power minus 2, it's minus 1 over x plus constant of integration. This is the implicit solution. We will be able to obtain the explicit solution by isolating y on the left-hand side. We just simply need to divide both sides by x squared, which gives us y of x as minus 1 over x cubed, and then we have plus c over x squared. So those are two most important methods for the first order ordinary differential equations, and if you have questions, please contact me. Thank you.